Yeah, like if you
Perhaps
just do a
while we're
screen
getting
share.
started, we can do a quick round of introductions, if that would be okay.
Sure.
Anne-Marie, Bryant, can I start with you?
Absolutely. So I'm very excited to be here. I've attended this group several times, but it's fun to be part of the presentation. I am the founder of AIMC, and we typically work at the intersection of the human experience and technology. So basically helping people to understand what's happening in our field and to adapt to it as quickly as possible so that we can move at the pace of technology. So I started my career with Ernst & Young doing this for some of the largest companies in the world, and then decided, hey, let's do it for the federal government instead. So that was in the early 2000s, and I've never looked back. It's just fun to have the opportunity to make an impact at such a large scale at the level where we can really make an impact on our country within the different agencies and organizations. So I'm really excited about Asif and Earl's depth of knowledge and Ruth pulling all of this together. And I think you're going to enjoy this presentation. It kind of pulls together a lot of different pieces that we've been talking about independently.
And
Great.
Earl, do you want to present yourself as well? You have a
Sure.
little presentation
Absolutely.
as well.
I'm Earl Warrington. For many of you, you may know me. I have 30 plus years in the government itself. I worked for GSA for many, many years, and then I also worked for SBA, and have now, I guess you could say, gone to the dark side. In that particular case, I'm a former agency acquisition executive, former contracting officer. I'm also a former organization CIO and a former organization CTO. So I've worn many hats within the federal service. I had a strong career in this particular piece. Sandy pushes me towards and identifies me as an architect, although I would say probably more of the business side of the house than I am from the technical side of the house. I've worn both hats, and we try to bridge that into making sure that we can actually communicate effectively between the technical side as well as the business side from that standpoint. So that's who I am these days.
Okay, this is Ruth Starr. Can I also say something? Can you see my screen?
Yep.
We can see your screen.
All right. I am learning a lot about Canva, and I'm learning a lot more that I thought I would know about semiconductor chips. And working with Asif has been a pleasure. And introducing a woman-owned business during Women's History Month is important to me. So I wanted to just say thank you, Anne-Marie. And I can move forward if you would like me to go to the next slide.
Asif,
if I may, I'll try to share my screen. Actually, I think I figured it out.
Okay.
Let me try sharing my screen if that allows me to share.
And perhaps as well, see if you'd introduce yourself.
Yes, absolutely. I will do that. So what do you have on your screen right now? Do you see my screen?
Yes, I see.
Yes.
We see
Which
it.
is the Semiconductor
full
Chips.
screen.
Yes.
Okay, data processing, right? Okay.
Yes.
Good. So my name is Asif. Thank you, Ruth, so much for allowing me to opportunity to work with you and learn from you. So as much as I try to share with Ruth about the small part of the semiconductor chips that is probably not in everybody's sight, but Ruth's ability to open up the whole world to me was amazing. So thank you, Ruth. Most of this presentation information that you'll see today is from Ruth's research. So very glad to present that information to you guys. And thank you to Earl. He's going to present the CHIPS Act side of the presentation. And with that, my name is Asif. I've been with ACT-IAC since 2021. I've been part of a few papers, some successful, some still struggling. But as far as my background goes, I've been working with data warehouse, data intelligence, manufacturing intelligence, and ERP solutions using data for the last 8 years. Prior to that, I was in the Air Force, where I worked in anti-terrorism investigations. I've done tours overseas. 9 out of 10 years I was overseas, which I can count the days that I've spent in US where I had to ask for visa to come back to US because I wasn't allowed to because I was stationed overseas, and coming back to US was like, having a foreign trip, been living in Dallas, Texas for the last 3 years. Prior to that, I lived in the East Coast as I was working on data intelligence. Has been great learning curve for me, transitioning out of the military and learning all this data. So I'm a learner for life. I've been learning for the last 8 years nonstop about everything I can, including blockchain, cybersecurity. So that's what I do now. I advise people on the infrastructure level, the cybersecurity level. However you are looking to work with a topic, I can probably put a few cents together and chip in, right? So Dr. Ruth made the introduction already. I made a little introduction myself. Anne-Marie and Earl, they already discussed topics here. So the next topic that we'll present is the data centers. You cannot walk a few miles without, learning something about data centers on the news articles and media about how much the data centers are growing and how giant these data centers are, right? If somebody built a few miles long data centers, now somebody else has to compete and build a bigger data center. And that's because the amount of data that we're collecting is growing in size, like exponentially, right? Quadrupling in size every few years, right? And we're not expecting to slow down anytime soon as far as how much data we'll have in the future. So these data centers are very important and leaves a giant footprint, everywhere they're being built. So here's a map of the data centers you will find, but if you zoom in a little bit more, you'll find more data centers in Virginia, and Virginia has tons of data centers, and there are very vital infrastructures that we need in order for defense to have cloud system access, for me and you to have cloud system access. But once they're separated, these data centers are able to be utilized for classified information, non-classified information, or just say kid playing video games like Fortnite, right? I don't even know is that the name of the game actually? Is Fortnite, right?
Yep.
Or Fortinet, I think the company.
No, it's Fortnite.
Fortnite, right. So the companies that you see here, Facebook, Google, they for obvious reasons, they have their operations in Virginia. And for the next slide, you will see, did that slide disappear? Yeah, there you go. This is a slide I wanted to talk about because Virginia is located right smack in the middle of, major populations within the United States. So within 11 hours of drive, you will reach 47% of the United States population. And to have a data center somewhere like Virginia, where your data travels as little as possible without really traveling the whole world, right? So when data travels, data in motion is a very important figure for users to have a good user experience, right? Without latency, that zero latency, right? So if you can remember 10 years ago when you opened a website, it took a few blink of an eye, right? Today, if that happens, you're like, okay, this computer is really slow today, right? Well, that's my opinion. I'm very impatient. I want to do things fast. So having these data centers in Virginia is very critical. So that way it reaches the majority of the users. And when I mean users, I don't mean me logging into LinkedIn, right? It's the thousands of users that are, working for a corporation, working for an organization, working in defense. So the data in motion is a vital component of being successful and providing data to the users. So the list of companies you see here, these are all users, right? And they have thousands and millions of employees that are continuously, having this data use, right? So data in use. We talked about data in motion, data in use. And every slide you'll see going forward, you will see this image recognition, natural language processing, and voice AI. So I want to hit on the privacy aspect for a few seconds, right? Because as I'm speaking to you through the voice is being processed in my laptop and is being processed in a data center somewhere. And then that data center is where it's being rested or stored at, right? So data at rest in a data center. So it's important that we have an understanding of data, how it's being stored, right? Data at rest, and how it's traveling, and when it's traveling, is it being saved? Is somebody else listening into this voice communications that we're having? So voice AI using natural language processing. Now my voice can be translated into text, and from that text, we are able to do so much analysis of what it is that I'm discussing, right? The content that is being presented here with voice, with the presentation, put them together, figure out the context of this presentation. Now, this is not that sensitive, right? But when millions of people are communicating using voice and having that data travel through the infrastructure and have it rest in the data center, we want to be able to build trust with the users who's communicating these ideas and information, right? Now, if you look at the image recognition piece of it, right? You take my voice, you take my data, you take the content of everything I'm speaking. Now you're able to put a face on it, right? It's Asif is discussing this topic here. So it's a full cycle of the AI's ability to say who said it, how they said it, when they said it, what was the context behind what they said, right? So if we have those data stored anywhere, we should be able to trust the fact that it's in a good hand, right? It's in a good hand, somebody who's actually accounted for, right? Somebody who will be respectful for our data privacy and not use that data for wrong reasons or malicious purposes. And obviously, you can think of countries that will use this information for purposes other than to be helpful towards us, right? So I think I'm going to stop here. I kind of give you a glimpse into the privacy side of things, and Earl will discuss some of the CHIPS Act topics, much better at discussing this topic than I am. So Earl, please take over.
No worries. I thank you, Asif. So we're talking about the CHIPS Act of America, or Chips for America Act, which essentially is infusing the concept of zero trust in the supply chain. So from that standpoint, we're talking about the basic level of pieces associated with this, the semiconductors, and how that's going to be governed, if you will, in that particular case. So as you can see from the journey map that's associated with this, it includes things like addressing issues dealing with China, third parties that we have zero trust with. Going all the way through to manufacturing facilities in the United States. So it's the focus of making sure that we can bring back the majority of the semiconductors back into the United States. The idea is to make sure that we give things like tax incentives and make sure that we have a solid supply chain infrastructure piece that's associated with this, and that we have all the natural resources to support it in that regard. So it tends to go from environment to economics, from economics into actually the business, and the business into actually delivering semiconductor chips to the private sector as well as the government sector. Let's hit the next screen. So the next screen, we talked a little bit about what this is all about. So 37% of the worldwide output in 1990 was part of the United States stand in that regard. Today, it's 12% worldwide output in 2020. So there's $20 billion from $20 billion from Intel that's currently working that to the Taiwan Semiconductor TSMC, who does $40 billion worth of work building semiconductors. That is a problem. As we all know, that Taiwan is right now under the shadow of the Chinese, and the Chinese are Chinese are looking to try and recover Taiwan. Part of that is because of the semiconductor business that they're in. They have the majority of the semiconductors in that regard. And so that creates a challenge for worldwide output of semiconductors and making sure that we have trusted sources of semiconductors. So the Chips and Science Act was passed back in August 2022 to help combat that and get us prepared for making sure that we can bring the market back here to the United States. And in that, they provided certain funding associated to that of about $52.7 billion to do a number of different things. And in that particular piece, it focused heavily in the R&D and workforce development at $13.2 billion, all the way through $39 billion in manufacturing money that's associated with this. So from that standpoint, we have a lot of money that's being pushed into the economy to build this zero trust supply chain to make sure that it's protected, that it meets privacy rules, and that it ultimately it will be housed on both federal as well as personal computers and personal appliances. As we all know, semiconductors, let me step back real fast on it. Semiconductors are used in 90% of what you do on a daily basis. It's in things like refrigerators. It's in things like ovens. It's in things like microwaves. It's in your cars. God forbid it's in your cars. And in those cars have smart chips in those particular pieces that help to govern what's going on in your vehicle. And you hear on a regular basis that people are looking at GPS and looking at the governors on those, particularly after accidents, to try and help solve for issues that are going on. It's just like it's in aircrafts. It's in everything that we're doing. So it creates a firestorm if that supply chain is whacked by third-party parties that are not exactly friendly to the United States in that regard. So let's hit the next screen. Whoop. All right. So on the next screen, we're talking a little bit about the CHIPS Act in terms of where some of the money is going, and so a lot of it's headed towards Department of Defense, microelectronic commons. It's got the R&D pieces that are supposed to be tied to this and the semiconductors, and more importantly, the workforce, because ASIF talks on a regular basis that there's a disconnect today between making sure that we have the right SMEs in part, and we have a lack of those, and having the right technologists in play to develop these type of semiconductors, which we have a lack of. And that's going to be the only way we can overcome that is to make sure that we have robust training efforts that are constantly building the community and making the community healthy. So right now, the community is not as healthy as we would like it to be. We need to focus in on the training exercises and the training networks that are associated with this to make sure that we can build that marketplace that can support the free world in that regard. So that's one of the reasons why there's so much money that's pushed into this particular piece, particularly, for example, with NSF, National Science Foundation. There's a $200 million workforce development, and they're doing it through grants. And so these are some of the things that are being used to try and build up that particular market space and build up jobs that are in that particular space. Because in this case, there's a need for people. We have a mismatch of people of labor. So labor is not skilled to do the work. We need to skill that labor, tie it to the business, and we need to do it relatively quickly before issues arise. And we need to bring back the focus of this particular piece back into the U.S. economy and bring it back into the marketplace. Let's hit the next screen. I think it's back to you, my friend.
Yes, sir. Yes, sir. Yeah. So I thank you, Earl, so much for that, because I couldn't have said any better. Because the brain dump, right? The brain dump that happened between 90s and 2022 between semiconductor chips being produced in the U.S. and now it's produced overseas. CHIPS Act is actually motivating people to come back to United States, right? So the engineers and developers and scientists, but even that return of these SMEs is not enough for us to continue into the next 10 years. So we need a giant effort to have college students and current professionals to convert into the semiconductor chips industry. So when we design in Texas, right, and we develop it in Arizona, somebody from Oklahoma can drive in with their Prius and pick up the semiconductor chips, put it in the trunk, and bring it back to Texas for manufacturing or whatever purposes you have, right? So we saw that shortages earlier in 2020, but when it comes to privacy, you want to close in on the borders of where the semiconductor chips are being manufactured and how they are manufactured and what purposes they are being utilized for. So one of the things that we mentioned about China, right now, there's a pressure in China to develop their own semiconductor chips, right? And a lot of businesses around the world are not allowed to sell their products, to China, right? With few restrictions such as ASML, we'll get a little bit more into that, but ASML is allowed to sell chips to China, but just not all of it, not the most latest technology, right? So U.S. wants to have advancement of chips that are manufactured and being used for the, excuse me, I lost my slide here. Okay, there it is. So earlier I mentioned about data in motion. I'm gonna go quickly through it because once you're inputting data into your laptop, your semiconductor chips is what processes it and puts it through the internet tunnel, right? If my slide would work, you will see all the slides are moving, but there it is. So this other semiconductor chips on the data center side is also picking up that data from the tunnel of data that's in motion, and then having that data center utilize that information for processing.
You'll have both those data points will be there. And also it creates a revision every time you update the database. So I've been a little leery because this database is going to get.
Okay. So I made a list of designers and manufacturers of semiconductor chips. Not all of them will manufacture to the level of TSMC. TSMC is the majority manufacturer of semiconductor chips. Some estimate is 90% of it. And this is a very vulnerable link here, right? Because TSMC went through COVID back in 2020, which disrupted the whole industry that utilizes semiconductor chips for their products. But not only that, it was the drought that caused semiconductor chips to not be produced as much as it did in 2019. So it was a once in a lifetime type of drought in Taiwan that caused TSMC to slow down in their manufacturing of semiconductor chips. But this list will tell you that the supply chain complexity is mind-numbing, right? Because who designs it, who develops it, and who manufactures it is a massive supply chain, and there's lots of interest to bring that manufacturing back to the United States for business purposes alone, right? The fact that if you manufacture it in US, you're able to sell it to the worldwide manufacturers that will manufacture using American chips. CPUs and GPUs are known, but I think I'm short of time, so I'm going to skip some of the information about CPUs and GPUs. But if you think about Google, Google's ability to design a chip and manufacture that chip in the backyard and have that chip being implemented in their phones, Google has an advantage to sell these products rapidly without delays, right? Current days estimates are that every chip that is brand new or has a new feature takes about 3 years from ideation to consumer's pocket, right? TPUs, tensor process unit, is Google specific. They use that for machine learning purposes. FPGAs, these are much easier as far as cost goes, but defense industry loves it because the ability to perform with FPGAs is much more user friendly than some of the other chips that are out there right now. How much time do I have, by the way, Keith? Do I have like 5 more minutes, or is this the end of the presentation?
Yeah, scheduled to go until 11:40, but we're flexible.
Oh, okay.
And of course, there are going to be questions,
Sure.
discussion following.
Yeah, feel free to start putting your questions in the comment. That way, I can read and Earl can read and Ruth can read and we can all answer it together. So the size of these chips are shrinking, as you would know, because 90 nm that we had back in 2003 versus the 5 nm that I have in my MacBook right now is the difference is that the gate where the information or the data or the particles that are traveling through is narrowing, and the narrowing of that information flow, what that creates is less power usage, right? Better performance, less degradation of performance, and the area of the semiconductor chips, right? So you can have a smaller and smaller devices based on the size of the chips, and the heating up of these devices will reduce because it doesn't require as much power as it used to, right? So PPA, your power, performance, and area, as you're shrinking the size of the semiconductor chips, you're utilizing this for massive data processing. And I think on the last slide, I will discuss data, how much data is being processing. But every year, every 3 or 4 years, you're seeing a better and newer NM, right? The semiconductor size that's, is going to be part of your daily life, right? So right now, if you have some tablets, like iPad, it probably has 10 nm or 5 nm, depending on what product you're buying. But the sizes are decreasing and you're able to process more data. And that's good because once you're able to process that much data, you are actually able to find more information faster, right? So ChatGPT, can't talk about any AI today without talking about ChatGPT because everybody is, impressed with how fast a ChatGPT can process data and give that data back to you so you can use it instantaneously, right? We've always had data, we just didn't have the processing power of these data. See, my slide just went haywire. Okay, I'm back. We just didn't have the way to process its data fast enough for a user to say, okay, this is worth my time, because within a few seconds, this AI is able to get back to you with an answer that you're looking for, right? So in machine learning process that you are experiencing today, they all have data collection, they all have data preparation, they all have to go through a data engineering and model training, right? Now imagine doing that hundreds of different times, right? Multiple iterations, as in just because you've received the data yesterday, well, today, 24 hours later, that data has improved or changed. So now you need the fresh data. So that data collection capabilities and training that model will have to continuously happen. And that requires a lot of semiconductor chips power. With that, yeah, I'm gonna just drop that 2 minutes, which I don't need anymore. I went a little bit fast because I didn't know how much time I had, but hopefully everybody was okay with the information I provided.
Okay,
So
this
if you
is
have
Ruth. I
questions,
would like also for Anne Marie to talk about the training aspects of this, because we did touch on preparing the workforce to be ready for this new thing that we're looking at in 5 years. Between 3 and 5 years from now, what are we seeing in the training area?
Well, that's really the same thing that we started out the presentation with. The challenge is helping people to understand what's happening. And as Asif talks about this, you can see the significant interaction. And as Earl was talking about the CHIPS Act, even understanding why that's happening and how that's connected to our everyday lives, that these things can't just be assumed, that we have to look at the whole supply chain and understand how this feeds into the different areas. So obviously different individuals need different aspects of this knowledge for their own personal use, but we need to understand the entire picture and then help people see how they fit into this process and what they need to know to go about their daily jobs and their daily lives. So it's a matter of this basic overview and then the in-depth in all of these various areas that Asif jumped through very quickly. I can't even tell you what all we covered as he was pulling together this presentation. But it's a matter of taking the whole picture and focusing in on where this impacts the human beings in their lives today and how the user experience changes based on the differences in this model. Ruth, is that what you wanted me to cover?
Yes, there was a question in the chat about universities and how the
Just
CHIPS
a
Act.
quick point of order. Since we're transitioning to questions, discussions, I'm going to go ahead and stop the recording.
Okay, thank you.
Let's see here.
So everybody can talk, yes.
Yes.
Everybody